Imagine this. It's a quiet night in early July 2025, and astronomers at the Atlas Observatory in Chile are sifting through the stars as they do every day, hunting for threats from the cosmos. But on July 1st, something impossible catches their eye. A streak of light hurtling through the void at speeds that defy comprehension, over 130,000 miles per hour. This isn't just any comet, it's 3I/ATLAS, the third confirmed interstellar object to grace our solar system, a visitor from the distant reaches of another star system, carrying whispers from a stellar neighborhood billions of miles away. As you're watching this right now on October 2nd, 2025, just one day before it makes its closest pass by Mars, 3I/ATLAS is accelerating toward its perihelion, the point closest to our Sun, set for October 29th or 30th at about 1.4 astronomical units, or roughly 130 million miles away. That's inside the orbit of Mars, folks, and it's picking up speed to a blistering 152,000 miles per hour, fast enough to zip across the entire continental United States in under 4 minutes. But here's the hook that will keep you glued to your screen until the very end. Whispers in the space community suggest SpaceX may have already launched a Falcon 9 rocket not just to watch this cosmic intruder, but to chase it down. An Intercept mission. The first in human history. If true, this isn't science fiction. It's the dawn of interstellar pursuit. Stick around, because by the time we unpack the science, the rumors, the ancient echoes, and what it all means for our future, you'll see why this story is rewriting the rules of the universe. And trust me, the twist at the end, it involves potential alien tech in humanity's next big leap. You won't want to miss it. Let's start at the beginning, because to appreciate the sheer audacity of what's unfolding, we need to rewind to how we even spotted this beast. The Asteroid Terrestrial Impact Last Alert System, ATLAS for short, is NASA's frontline defense against cosmic bullies like asteroids that might fancy a date with Earth. On that fateful July 1st, their telescope in Chile flagged an anomaly, an object cataloged initially as A11PL3Z, moving on a hyperbolic trajectory that screamed not from around here. Within days, follow-up observations confirmed it, an eccentricity greater than 1, meaning it's not bound to our sun's gravity. It's a flyby artist, slingshotting through our system before vanishing into the interstellar black. Officially dubbed C/2025N1, Atlas, and later 3I/Atlas, the I for interstellar, the third in the series. It's a comet about 5 to 10 kilometers across, with a nucleus that's already revealing secrets through its glowing coma and tail. Hubble snapped images on July 21st, when it was 277 million miles from Earth, showing a dust loss rate typical of comets warming up far from the Sun, about 300 million miles out at first detection. Spectroscopy from ground-based telescopes and the James Webb Space Telescope has picked up water ice, organic compounds, an unusual abundance of carbon dioxide, and even nickel, elements in ratios that hint at formation conditions utterly alien to our solar system. But size-wise, oh, it's a monster. Recent estimates peg its mass at over 33 billion tons, dwarfing the previous interstellar visitors by orders of magnitude, 3 to 5 times more massive than Oumuamua or Borisov combined. That's not just big, it's anomalously so, with no detectable non-gravitational acceleration from outgassing, which implies a density and structure that's got Harvard astrophysicist Avi Loeb raising eyebrows. This constitutes a major anomaly, he wrote in a recent paper, suggesting it could be a rocky behemoth or something engineered to withstand the void. Picture it, a cosmic iceberg, 10 kilometers wide, hurtling at 58 kilometers per second excess velocity relative to the Sun, 36 miles per second. Its hyperbolic path taking it from the outer Oort cloud fringes, past Jupiter's orbit, skimming Mars tomorrow on October 3rd at about 30 million kilometers, then looping in for that solar close shave before exiting toward the constellation of Libra. No collision risk for Earth. Its closest approach to us is 1.8 astronomical units, or about 167 million miles on December 19th. But the implications? They're galactic. To grasp why 3I/ATLAS has the world buzzing, Let's zoom out to the history of these interstellar intruders. It all kicked off in 2017 with Oumuamua, the Hawaiian word for scout, that perfectly captured its role as the first confirmed visitor from beyond. Discovered by the Pan-STARRS telescope in Hawaii on October 19th, Oumuamua was a reddish, cigar-shaped oddity about 100 to 1,000 meters long, tumbling end over end with no coma or tail, unlike any comet we'd seen. It accelerated anomalously, not from jets of gas, but something subtler, sparking wild theories from solar radiation pressure to, yes, alien light sails, courtesy of that same Avi Loeb. Traveling at 26 kilometers per second, it originated from the direction of Vega and Lyra, having wandered the galaxy for hundreds of millions of years. We had just 11 weeks to observe it before it faded into the dark, leaving us hungry for more. Then came 2I/Borisov in 2019, a more familiar face. Spotted on August 30th by amateur astronomer Gennady Borisov in Crimea, it was a bona fide comet, 1 kilometer across, with a prominent tail of carbon monoxide and hydrogen cyanide, gassing out vigorously as it approached perihelion at 2 astronomical units. Moving at 32 kilometers per second, it hailed from the constellation Cassiopeia, possibly ejected from a system like Kappa Draconis. Unlike Oumuamua's enigmas, Borisov behaved normally, giving us our first taste of interstellar chemistry, organics that mirrored our own comets, but with tweaks suggesting different stellar nurseries. Fast forward to 2025, and 3I/ATLAS blows the doors off both. Discovered closer in, 4.5 astronomical units from the Sun, it's already shown a faint tail by late August, captured by Gemini South on the 27th, growing as it heats up. Its age, potentially the oldest yet, with models estimating just 0.8 billion years since formation. Younger than Borisov's 1.7 billion, but still predating our solar system's 4.6 billion year youth. And that mass, 33 billion tons, makes it a heavyweight, possibly a fragment from a disrupted planet in another system, hurtling through space for eons before crashing our party. These 3 objects aren't flukes. They're proof that the galaxy is littered with ejecta, comets, asteroids, maybe even rogue worlds, tossed out during planetary formation. Estimates suggest thousands pass through our system yearly, but most are too dim or distant to spot. Until Atlas and Pan-STARRS upped the game, we were blind to them. Now enter the rumor mill that's got everyone from backyard stargazers to Pentagon analysts on edge: SpaceX's Falcon 9. Within weeks of 3I/ATLAS's discovery, unconfirmed reports swirled through forums like Reddit's r/SpaceX Master Race in X, formerly Twitter, about an unscheduled Falcon 9 launch from Cape Canaveral. No presser, no live stream, just a quiet liftoff in mid-July, payload classified under NSSL Phase 3 contracts with the U.S. Space Force. Videos on YouTube like Falcon 9 Intercept mission against 3I/ATLAS, then this happened, claimed trajectory data from amateur trackers showed the rocket's upper stage veering toward the comet's path, deploying what could be microprobes or beacons. Is it true? SpaceX hasn't commented, but remember, Falcon 9s routinely haul secret payloads, over 50% of 2025 launches so far, per public manifests. And with 3I/ATLAS's velocity, 210,000 kilometers per hour at peak, catching it demands precision-only reusable rockets like Falcon can muster on short notice. Think about the physics for a moment. It'll blow your mind and make you hit that like button if it hasn't already. Interstellar objects like 3I/ATLAS aren't orbiting. They're on escape trajectories, unbound by the sun's pull. To intercept one, you need delta V, change in velocity, that rivals escaping Earth's gravity well multiple times over. Falcon 9's Merlin engines deliver 1.7 million pounds of thrust, with the second stage capable of 5 kilometers per second in orbit, but matching 58 kilometers per second hyperbolic excess? That's sci-fi territory, yet simulations from Southwest Research Institute, SWRI, show it's feasible for future missions. Launch a probe, use a Jupiter gravity assist, and rendezvous within a year. For 3I/ATLAS, the window slammed shut post-discovery, too late for a dedicated chaser, but an opportunistic Falcon 9? It could deploy CubeSats to tag the comet with radio beacons or sample collectors, turning passive observation into active engagement. Rumors suggest just that. Not a direct hit, but a dust-sampling flyby of the coma, that ethereal cloud of gas and debris trailing like a 100,000-kilometer banner. Why dust? Because that's where the gold is. Isotopic ratios untouched by our sun's radiation, clues to alien chemistry from a star that died billions of years ago. And speaking of chemistry, let's dive deeper because this is where 3I/ATLAS gets truly revolutionary for astrobiology. Comets are time capsules, frozen since the dawn of their home systems. Our solar system's Hale-Bopp and Rosetta's 67P revealed amino acids, sugars, and phosphates, the building blocks of life. But interstellar ones? They're pristine imports. Borisov showed CN radicals and CO at levels 10 times higher than solar comets, hinting at carbon-rich formation environments. 3I/ATLAS ups the ante with its CO2 surplus and nickel spikes. Nickel, rare in comets, abundant in planetary cores. This could indicate formation in a metal-enriched disk around a high-mass star, notes a Smithsonian analysis. Imagine analyzing samples. Different D/H ratios, deuterium to hydrogen, could prove water and thus life is universal, not a solar system quirk. Panspermia theories gain traction. Maybe microbes hitched a ride on Oumuamua, seeding Earth eons ago. Or, chillingly, the reverse. We're the invaders, our ejecta carrying Earth life to other worlds. Studying 3I/ATLAS could confirm if life's ingredients are galactic common currency, reshaping astrobiology from speculation to science. But hold on, it's not all stargazing wonder. This story has a darker edge. Planetary defense. The U.S. Space Force isn't just about satellites, it's prepping for threats like Oumuamua on steroids. Falcon 9's classified payloads often test kinetic interceptors or directed energy weapons, lasers that could nudge asteroids. What if the rumored launch was a dual-use op? 3I/ATLAS at 152,000 miles per hour is perfect target practice. Too fast for nukes, ideal for tracking algorithms or signal bouncing. Analysts whisper it doubled as a test for the Near mission concept, intercepting near-Earth objects with mirrors to deflect them. And get this, preliminary data shows Earth's magnetosphere flickering with minor spikes in early September, coinciding with 3I/ATLAS's Jupiter crossing. Coincidence? Or electromagnetic echoes from a probe's comms array pinging the comet? The magnetosphere's sensitive to solar wind, but high-energy events, like experimental beams, leave ripples. If SpaceX fired signals at 3I/ATLAS, we'd see exactly that. Revolutionary? Absolutely. Terrifying? You bet, because the next visitor might not miss. As we hurtle toward tomorrow's Mars flyby, let's talk observations ramping up. ESA's Mars Express and Trace Gas Orbiter are primed, their spectrometers tuned to sniff 3I/ATLAS's wake from 30 million kilometers out. NASA's Perseverance rover might even tilt its mass for a peek, though distance limits resolution. JWST's NIRSPEC has already logged infrared spectra, revealing complex organics that scream prebiotic soup. Ground-based giants like Gemini and VLT are stacking data nightly, with Cobb's reports showing a coma diameter of 0.7 arc-minutes as of October 1st, magnitude 12.7. Faint but growing. By perihelion, it'll brighten to binocular visibility, a ghostly streak in the dawn sky. But proposals for closer looks? They're feverish. SubEDURI's Comet Interceptor, launched in 2029, could chase future visitors, but for 3I/ATLAS, scientists floated redirecting aging probes like Voyager 2, now 48 years old, via Jupiter Slingshot for a 2026 rendezvous. New Scientist reports feasibility studies for repurposing Lucy, Jupiter Trojan's mission, or even a quick and dirty Falcon heavy payload. The trajectory is within intercept range, SWRY's Alan Stern enthused. If the Falcon 9 rumor holds, it was the proof of concept. Now for the mind-bender that ties history to the heavens. Ancient alignments. No, 3I/ATLAS didn't inspire Machu Picchu, built 500 years ago. But its inbound path from Lyra echoes celestial patterns etched in stone millennia back. Göbekli Tepe in Turkey, 11,000 years old, features T-pillars aligned to Sirius and Cygnus, constellations near 3I/ATLAS's exit vector. Egyptian pyramids track Orion's belt, while Mayan observatories at Chichen Itza align to solstices, events mirroring hyperbolic paths. Coincidence or cultural memory of past visitors? Biblical wandering stars and Sumerian epics describe sudden bright objects defying orbits, vanishing forever. Eerie parallels to interstellar flybys. A 2025 ResearchGate paper proposes Hapgood's Earth crust displacement model, links sites like these to comet impacts, suggesting ancients tracked ISOs as omens. If 3I/ATLAS's geometry mirrors these, it hints at cyclic visits, predictable every few millennia. Monuments as early warning systems? That's the stuff of epics, and it makes you wonder. Did our ancestors chase these too, with stone spears instead of rockets? Houston, we have a problem. I don't think this is Florida. Pause for dramatic effect. Luckily, I didn't need NASA. I needed a legal army. It turns out there's an injury firm called Morgan & Morgan, America's largest injury law firm, with over 1,000 attorneys and more than 100 offices nationwide. I tried calling one of those local lawyers with cheesy jingles. I was on hold longer than a Mars launch delay. Meanwhile, Morgan & Morgan helped a client in Florida get $12 million after the insurance company only offered $350,000. They only get paid if they win your case. No upfront fees. You can file a claim right from your couch or from the jungle. Here's how easy it is. Click the link in the description or scan the QR code on screen. If you're ever injured, whether by a rogue asteroid, metaphorically speaking, you can check out Morgan & Morgan. Their fee is free unless they win. Start your claim by clicking below or scanning now. Back to the stars. With that earthly detour, let's get personal. Why should you care about a comet zipping harmlessly by? Because if the Falcon 9 rumors pan out, we're not just observers anymore. We're hunters. Success means protocols for the next one. Automated ATLAS, alerts triggering SpaceX ride shares with interceptor kits. Failure? It spurs innovation, like SWRI's validated designs for 100-day intercepts. Astrobiologically, samples could prove life's universality, fueling SETI 2.0, scanning ISOs for technosignatures. Loeb's team modeled OIT's trajectories, showing low-energy paths to 3I/ATLAS, even pondering if its low perihelion is deliberate. Alien probe? Unlikely, but the anomalies, mass, composition, no outgassing boost, echo Oumuamua's weirdness. NASA's response? Natural object. But they're watching like hawks, threading it all. Discovery sparks rumors of SpaceX action, validated by mission studies. Anomalies fuel tech debates. Ancient echoes suggest deep timescales. This is humanity's interstellar playbook, Chapter 1. The Falcon 9, whether it tagged 3I/ATLAS or not, proves we're ready to play. Next visitor, we'll intercept, sample, defend. Hit subscribe to track the Mars flyby tomorrow and beyond. We've unpacked the facts, the wilds, the futures. Now it's your turn in the comments. Alien craft or cosmic luck? Watch till the end? You did. Legend. See you in the stars.